Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's illustrate the limit, law, or theorem for any linear function. This would be the part 1 of this limit theorem, since there is one thing that we also need to really emphasize for this before we proceed to part 2 and all other limit theorems. A linear function is a function where the highest degree of x is just equal to 1. The simplest example over here is we have f of x, let's say x plus 5. This is a linear function because we only have one variable at the same time. The highest degree of x here is 1. Now, for this limit theorem, we are given, say for example, if we are solving for the limit of this given function as x approaches to a certain constant. Let's say here, let's have the limit of x plus 5 as x approaches to, let's say, 4. We can solve for the limit of this by distributing the notation for the limit for both of the terms. That's one property that we could apply for our limits, where, say for example, if we have the limit of a function, let's say ax plus b in general linear function, as x approaches to c, we can represent it like this: the limit of just the first term as x approaches to c, and you use the operation separating the terms, plus the limit of the second term as x approaches to c. The sum of the two limits would be equal to the limit of the entire expression. So here we can represent this one as the limit of just x as x approaches to 4, plus the limit of the constant 5 as x approaches to 4. From here, we can now solve for the individual limits of these two, because we have here the limit of an identity and we have here the limit of a constant. In our previous two limit theorems, we know that the limit of our identity is the constant c here, where that variable is approaching 2, so you have here 4, and the limit of the constant is the constant itself, so 5. That would be equal to 9. In short, the limit of the entire function f of x, which is x plus 5 as x approaches to 4, is just equal to 9. The second form here, let's say another function, let's just, in this case, g of x, or let's put it a little bit higher here. We have here g of x, let's say x minus 4. So if we are going to solve for the limit of g of x as x approaches to c, in this case, let's try to declare a certain constant c. So we have x minus 4 as x approaches negative 3. Okay, so we simply break down or distribute the limit here. So we have the first term, limit the first term as x approaches to negative 3, then minus, because it's subtraction, the limit of the constant 4 as x approaches negative 3. So we have here, of course, again, the limit of an identity is this value, negative 3, and the limit of the constant is the constant itself, minus 4. So the answer here is negative 7. This is again part 1, because we need to emphasize this, as this would be very essential in showing as well part 2. In a part 2, we will have a general form of a linear function where a is no longer 1, because in this case, we have f of x, a is 1, and here a is 1 as well, because we only have x. In the next example, in part 2 of this limit theorem, we will have other forms where a is no longer 1, and to show the process of solving for the limit theorem of the linear function, which is on part 2, we might be able to use some of these concepts. So what are you waiting for? Subscribe now!